Welcome to class. Today we shall be looking at balancing of chemical equations, okay? And we have a couple of equations here. I shall be doing equation 1 and I'll show us the steps we need to take while I leave us to handle equation 2 and drop our comments and solutions in the comment section. Why do we balance chemical equations? We do so in conformity with the law of conservation of matter that says that matter can neither be created nor destroyed, but it can only be changed from one form to another. Where your equations are not balanced, you have simply violated that law. You are simply saying that matter has actually been created and perhaps some of it has been destroyed. We are looking at ordinary chemical equations or reactions, not the nuclear regime where we have radioactive substances, okay? So we have for equation 1, copper 2 sulfide, which is a solid here. The subscript S tells you is a solid, combines with oxygen or bonds in oxygen or undergoes combustion. Here we have G, gas, and produces copper 2 oxide, which is still a solid, and also sulfur 4 oxide, which is still a gas. The second equation, we have ammonia, still burning in oxygen or undergoing combustion, as the case may be, producing nitrogen oxide and also steam. So we are going to balance the first one. I want to say here, balancing of chemical equations doesn't have a formula. It's experience, okay? You keep doing it by trial and error. But there's a method, a little mathematical method I want to introduce here. So let's do it. So here we have here that for number 1, which I'm going to take, we have copper 2 sulfide, okay? That's a solid. And that it combines with oxygen gas, okay? It bonds in oxygen, and when that happens, it produces copper 2 oxide, which is a solid. Copper 2 oxide, which is a solid, and also sulfur 4 oxide, okay, which is a gas. What we do first is to look at the number of atoms on both the reactants and also the product side. The left hand side, what we have are called reactants. On the right hand side of this arrow, what we have are called products, okay? So for copper, there are 2 atoms of copper. The subscript 2 tells us there are 2 atoms of copper. On the right hand side or the product side, we also have 2 copper atoms. So copper, as an element is balanced, okay? And then we look at sulfur. There's just 1 sulfur atom and also just 1 sulfur atom on the right hand side, so it's balanced. We come to oxygen. We have 2 oxygen atoms here. This subscript 2 tells us there are 2 oxygen atoms, okay? But on the right we have 1 oxygen atom and also 2 here, making it 3 altogether. That means there is a deficit of oxygen atoms on the reactant side. So we come over to where we have fewer atoms of oxygen. Here we have 2, on the right 3. So I can bring in a little mathematical method. I can simply say, if I have 2 oxygen atoms, 2 oxygen atoms multiplied by what? Okay, I can call that x will give me 3. I need something I'll multiply by 2 so that the result will be 3. Okay, this becomes a little equation. This is the coefficient of x2. So if I divide both sides by that 2, I do this, divide this side by 2, I divide this side by 2. So I can end up saying that x equals 3 over 2. That means if I have 2 oxygen atoms, if I multiply 2 by 3 all over 2, it's going to give me 3. So I can come in here and insert 3 over 2. The denominator or the LCM is 2, so I shall multiply both sides of that equation by that 2. If I do so, I'll end up having here 2 copper 2 oxide, okay, still, or copper 2 sulfide rather. It's a solid. Now when we multiply 3 over 2 by 2, just imagine having 2 multiplied by 3 over 2. Okay, the 2 will do away with the 2, leaving us with 3, so the result will be 3. So here we are going to have 3 oxygen atoms, or 3 moles of oxygen gas rather. On the product side, we multiply everything by 2. Okay, so there we are. That's beautifully done. And also we multiply sulfur 4 oxide 2 moles. It will now become 2 moles of sulfur 4 oxide. That's what we have. Okay, so let's check if our equation is balanced. For copper, we have 2 times 2, making it 4. On the right, on the product side, 2 times 2, 4. Copper is balanced. Sulfur, these 2 moles affect the sulfur atom. So there are 2 sulfur atoms on the left hand side. On the right, these 2, okay, tells us there are 2 sulfur atoms as well. Sulfur is balanced. Come over to oxygen, 3 moles of oxygen. Okay, so 3 times 2 gives us 6 oxygen atoms. On the right hand side, these 2 tells us there are 2 oxygen atoms here, and these 2 multiplied by these 2 gives us 4. So 4 plus 2 will give you 6. That means there are 6 oxygen atoms on the reactant or left hand side, and also 6 on the product side. So our equation is balanced. Our equation is balanced. I'd like you to try your hands on the second equation. Ammonia undergoes combustion, produces nitrogen oxide and steam. Do the balancing yourself and then drop your solution in the comment section.